We would like to introduce the Rosenberger PIM Alpha to you and how to use it. This is the PIM Alpha base unit with a large touchscreen for easy operation and protected by its front cover. The PIM Alpha has several interfaces: PIM test port, optional VSWR test port, isolation test port, USB, and RJ45, as well as 2 batteries. There are 2 metal ankles for hoisting the unit to the tower top. On the back side, the different filters can be changed very easily. Press the 2 red buttons and the latches are released. Take the filter out and insert the next filter. Then press the 2 red buttons again, hold them, and press down the latches at the same time. Be sure that the filter is at the correct position and that the red 2 buttons click. The PIM Alpha unit is covered by the fully flexible carry bag, with openings for all important positions. We offer 2 accessory bags to carry all needed equipment with you for low PIM testing on site. The backpack for all accessories and 1 filter unit. The carry bag for all accessories and up to 3 filter units. The backpack covers the test cable, power supply, cleaning kit, filter unit, duster for cleaning, torque wrenches and pliers, different needed low PIM tester adapters, low PIM load, and a tablet for remote control of the PIM Alpha unit. The carry bag covers all the needed accessories like the backpack. Up to 3 different filter units plus spare batteries and a larger high-power PSU. In the front you have all the low PIM adapters, tools, and additional space for the tablet. The Rosenberger Site Analyzer PIM Alpha is designed for the most easy, flexible, and reliable handling of PIM testing on site. It makes it very easy for the test engineer, as no calibration or warm-up of the unit is needed. Switch on the unit and after less than 60 seconds you can start with your measurements. No need of calibration ensures high quality and reliability of the test results. The PIM Alpha provides full flexibility, technical and economical, because you have 1 base unit where all different filter units, different frequency bands, can be plugged in according to your needs. The batteries for the PIM Alpha can be exchanged very quick and easily during operation by replacing them one by one. 1 battery must always stay in the unit. Measurements can be performed only if both batteries are inserted. The spare batteries can be charged in the external charging unit. Therefore, you are always able to operate with batteries. The capacity of each battery is 99 watt-hours. Therefore, they are capable to be taken with you as hand luggage if you transport the PIM Alpha via aircraft. The main unit can be checked in with the offered transportation box. Please check the caps on the battery are open before inserting the battery into the unit. The PIM Alpha software is intuitive and easy to operate. Here you see all testing modes and functionalities the PIM Alpha software can offer. At Common Settings, you can define your language: English, German, or Chinese. The color theme of the display includes night mode for light-restricted environments and day mode, which will help the visualization of the screen whenever you have bright light. For configuration of the Wi-Fi, you will find a hotspot option to connect the tablet for remote control, a client option to connect the unit directly to the internet, and a disable option to save battery from Wi-Fi transmission. A CSV file with velocity information concerning different coax cables can be loaded. All measurements are stored on the unit automatically and kept for the duration mentioned here. The tick in the box for check RL should always be set, because PIM testing with high TX power will only start if the reflection is not too high, therefore there is no open port, so no one can be injured by an open interface. To enable the power sweep feature, simply tick the box. At Device Info, you see all relevant parameters of the unit, like part numbers and serial numbers of the unit, filters and batteries, current status of the batteries, and temperature of the system. Close the display with the protection cover. Turn the unit round, open the bag and press the 2 red buttons for opening the latches. Take out the filter and replace it with the next one needed. Check if all interfaces are clean. If not, take a duster to clean. The unit always recognizes the filter which is put inside. All settings for testing are done automatically based on the inserted filter. The PIM test port is always on the filter. Filters are available with 4310 or 716 interfaces. If you have a filter with a 716 and would like to switch to a 4310, this can be done by changing the test port of the filter. All testings via the PIM test port are dedicated to the used filter frequency. If you match a PIM alpha base unit and a new filter for the first time, the PIM alpha and filter need to get to know each other for the correct distance to PIM and distance to fault return loss testings. Therefore, zeroing is needed. This means to set the reference point for the distance testings. Go to the test mode DTF. Zeroing RL is achieved with no connection to the filter. Press the button Zeroing RL. A low PIM zeroing adapter generating PIM IM3 of about -70 dBm at 2 times 20 watts needs to be connected to the filter output and terminated with the low PIM termination. Then start the zeroing PIM. After successful zeroing, the 2 buttons disappear. You can always change the test reference if you enable the zeroing in the settings of the DTF mode. E.g., if you would like to have the DTF testing start from the end of the jumper cable. Then you need to take care to always use the same jumper cable. If not, the length results will differ by the difference of the used jumper cable. Now, I would like to go through with you the various test modes the PIM alpha can provide you. For all PIM testing modes, the test power can be set from 2 times 23 dBm and up to 2 times 46 dBm continuous wave. For the PIM testing modes, PIM can be tested for IM3 and up to IM19, depending on the used filter frequency, and can be easily changed in the settings. In the 2-tone mode, 2 fixed frequencies, F1 and F2 are applied to the system, and the intermodulation level is measured in the corresponding frequency. In the sweep mode, F1 is upswept over a frequency range while F2 is fixed, and then F1 is fixed while F2 is downswept over a frequency range. Thus, all the intermodulation frequencies are covered in the range of the filter. In DTF, the distance to the worst fault of both PIM and return loss can be defined. In spectrum analyzer mode, it is possible to determine if the external interferences are causing trouble to the system. The power sweep measurement would allow you to determine the BTS output power, which becomes a PIM level within the requirement. To document all measurements, the PIM alpha offers a reporting module. Therefore, go into Report and create a new report as follows. Find Report Settings and set the name of the test engineer. Here you can choose the folder where the report should be stored. If you would like to get the results as CSV data, this is also possible. If you tick the box for merge plots of same measurement type per section, you can also get test results done in the same mode in one graph. Without the tick, you can get each test on its own individual graph. Enter report title. Create new sections. Recommendation is to do an individual section for each sector and polarization. For the section naming, you can define your own buttons above the keyboard. For this, please follow the app note defining own buttons for section names. With this, it is very quick and easy to do the correct report settings. The greatest quality is ensured as the PIM alpha is testing in the same mode as a BTS is operating, CW power used for testing. This means the test is equal to the situation later on the BTS loading the radio access network, jumper, connectors, feeders, diplexers, TMA, antennas with power. This results in the highest quality for the test results, which makes it less dependent on the test engineer. If you perform PIM testing on site, you should start always with the spectrum analyzer mode, because if you get interference from outside, it could show up as a PIM later on at the testing. If you have interference from outside, you should disconnect the BTS antenna and terminate your feeder line with a low PIM termination, which can handle your test power. The spectrum testing is correct, and we store the result to our report. Next test is VSWR-RL. As we are testing a complete system including antenna, the limit is around -15 dB for return loss. For all testing, it is important what the BTS port sees. A filter combiner is used to combine both carriers at the test port of the unit. This always requires at least 10 MHz frequency gap between the combiners due to design. Otherwise, losses, PIM size and weight would increase. Save the result to the report. Now we are starting the PIM testing with two-tone. In our test setup, we have our test cable with a length of 3 meters, a PIM source creating -74 dBm PIM, IM3 at 2 times 20 watts, and a low PIM termination. The two-tone PIM testing shows a fail. The result we save to the report. Same for the sweep PIM testing. Test results saved to the report. Now we go to the DTF mode, as we would like to find our PIM problem. In Settings, we enter the information about the RF line. In our test setup, the velocity ratio of the test cable. Also, we set the distance how far we would like to test, e.g. 150 meters. For each coax cable, we have a different velocity ratio, which shows a different electric length for each component. In this tower installation, we have a jumper connecting the BTS to the feeder line, a long feeder cable, and another jumper connecting the feeder line to the antenna. The lengths of these cables, as well as their velocity ratio, need to be entered into the unit for a precise measurement. Also, the test cable needs to be included as a cable section. As an example, consider the test of the whole coax line. We add the 3 meter test cable, then the first jumper from the BTS for the feeder cable with 2 meters. After that, we add the 7/8 feeder with 20 meters, and finally the jumper between the feeder and antenna with 1.5 meters. So we are ready to test DTF. For other passive or active components in the network, the electrical length can be completely different from the physical length. In general, antennas have around 8 to 12 meters electrical length. TMAs can reach up to 15 meters, and combiners around 1 meter. Start testing by pushing the button Start. The PIM alpha is now calculating the distance to the PIM failure based on the velocity ratio. The accuracy is less than 0.3 meters. The test result shows a PIM problem with a -74 dBm at a distance of 3.05 meters. Now we fix our PIM problem and perform the DTF testing once again. The PIM alpha always shows the worst PIM problem. Therefore, if we fix the first one, it can be that on another location a second PIM problem, not as bad as the first one, is detected. The DTF measurement may not show a high accuracy PIM source when external interferences are received through the antennas, unless this is a fixed external PIM source. That is the reason why doing a spectrum analyzer measurement is important before the PIM tests. Now the DTF testing is correct. Save the measurement and enter comments. Perform the PIM two-tone testing again and save the result to the report. Same for the PIM sweep testing. Finally, create the report about all the performed testing. If you would like to change or add comments on the performed measurements, you can always do this by going into the report and choosing the dedicated measurement. After that, go into the Mode report and press the button Create a PDF. Now, a PDF report is generated and stored at the path which is defined at the report settings. If the PIM source is impossible to be eliminated at the moment, an alternative is to reduce the power in the BTS. A BTS power reduction of 1 dB may reduce also the PIM level by 4 dB. In this case, we have a PIM source around -100 dBm, while the limit PIM is -110 dBm. In the power sweep mode, we choose the limit power for the PIM, and the unit will increase the output power from 20 to 46 dBm. The point where the PIM level crosses the limit line means the maximum output power of the BTS will not cause high PIM in the system. Here, using the marker function, we see that an output power lower than 37 dBm can solve the PIM interference. With the DTF mode, you can very easily define the length of a diplexer, antenna, or TMA by keeping the end of the cable open. The distance calculated is based on the same technology for PIM and VSWRL testing. The cables are easy to define as the velocity ratio is known. This is different to diplexers, antennas, and TMAs. To keep the accuracy high, for your distance measurements on site, the used components, diplexers, antennas, TMAs, should be tested individually to know at what length they will show up at the distance testing. In our case, we are testing one diplexer combining high band and low band frequencies. We connect our 3 meter long jumper cable to the unit, terminate the other input port, and keep the combining port open. With the DTF-RL mode, we can now test how long the diplexer will show up on the distance testing. In our case, we have a length of 3.87 meters for the high band. As we set our test reference at the filter, we now know the diplexer has an electrical length of 0.8 meters for the high band. With the accuracy of the PIM alpha, you can now identify clearly if the PIM problem is on the input or output port of the diplexer. Same is needed for the used BTS antennas. As all antennas are different, you need to evaluate the length of your used antennas to be able to define the end of your controlled RF line. This is where the signal is leaving the antenna and going into the air, which is important to define if the PIM is internal or external. You can do this by connecting the antenna to the PIM alpha and putting a steel wool on the cover front of the antenna as PIM source. The testing has to be done with the DTF PIM functionality. Test the antenna if the PIM is OK. Please check carefully the test environment beforehand. Either do it in a green field or antenna test chamber where you can access no external PIM. Pay attention that you are not too close to the high power radiating field to prevent health risks, especially to your eyes. Use the PIM two-tone or PIM sweep testing to check the antenna's performance. Here we show the test on PIM two-tone. You can see a very good PIM performance on a Rosenberger BTS antenna. Now we put the steel wool onto the antenna and start the PIM two-tone testing once again to see what PIM level the steel wool creates. In our case, we get a PIM of -38 dBm, IM3 with 2 × 20 watt. With the PIM DTF, we can now check how long the antenna appears. The results of 4.59 meters shows the position of the steel wool. We are using the 3 meter test jumper. Therefore, the antenna has a length of 1.55 meters, electrical. For all the evaluation of component lengths, you have to refer these results to the use velocity ratio. In our case, we used the same velocity ratio as we had for the test cable, 71%. All testing functions of the PIM alpha site analyzer are achieved without any calibration on site.